Welcome to our lecture. We'll be discussing estimation, estimation with small and large samples. I'll begin by explaining what we call the standard normal table. The standard normal table has an area to the left and to the right. The areas to the left have Z figures, which are called negative Z figures. So whenever we're dealing with estimation, ideally, we are looking at the area under a normal distribution curve with the assumption that each side has 50%. This is 0.5 and this is 0.5. So the area under the graph collectively is 100% or 1. So the figures or the numbers on the left side of 0 are negatives. This is -2, this is -1. And the areas to the right are positive. This is +1, and this is +2. So if we're dealing with the area under graph, the reading is starting from this. This is the starting point. So if this is the starting point, if we're going to read an area, for instance, 1.0, from here up to 0, it is 0.5. From here up to this point here, we need to check through the table reading. So when we go to our table, we're going to check under 1, +1. So we'll go here, scroll down here, +1. So 1.0 is here. So meaning the reading 1.0, this is 84. This is 0.8413. So this is what it means, that the reading from here to here is 0.8413. So this is the reading from here up to here. This is about 84%. But also we have another one, but it's on the negative. Obviously, if we're going to read from here to here, the reading should be smaller than 50%. So go to the table and check the reading at -1. So when we go here, -1 is here, -1.0, so this is 0.15866. So this is what it means, that the reading from here to here is 15%, or 0.15866. All right, so it starts from reading, then we go to, so suppose we had a reading here 1.23. 1.23. So we check under 1.2 and 0.03 where they meet. 1.2 and 0.03. So it's a positive, so we go under 1.2 and 0.0. So 1.2 here, and where it means 0.03 here. So this will be 0.89065. 0.89065. So this is the reading for 1.23. So the whole reading here is approximately 89%. All right, so now I want you to tell me, what could the reading be 0 is here, 1.67, 1.67. Where do we go? The reading table, 1.67. Where do we go? Yes, Patricia, 1.67.
You go to 1.6 and then 0.7, which will be 0.9, 95%.
Yes, 0.95254, so 95%. Okay, so 0.952. All right. So now this is how we do the reading. All right. Suppose we had -2. Where do we go? Suppose we had -2 somewhere here. We're looking for this reading here. Where do we go?
Negative 2.0.
-2.0. Good. So we check here. We use the -1. It's 2.0. So here, this is what? 2275. 0.02275. So 0.02275. All right, together. So this is how we do the basic reading. Now, we also need to learn how to read the confidence intervals. Confidence interval is simply a range between which a mean must lie. Confidence interval is given by the range within which the mean must lie, plus and minus and a margin of error. For instance, if you are told that it will take you 20 minutes to drive to school, plus and minus 5. So the range will be, if you're early, you'll be there in 15 minutes. If you're late, you'll be there in how many minutes? In 5 minutes. You always start with the lower bound to the upper bound. So when we're dealing with samples more than 30, our formula for the mean is given by x plus minus z alpha over 2 standard deviation divided by the square root of the sample size. That is the formula that we use. Now, how do we calculate this z value? So we have what we call a confidence level. These are all numbers above 50, but we have 4 common ones. We have 99, we have 98, we have 95, and we have a 90%. So these are called what? Confidence levels. When you subtract from 100, the difference is called the significance level. We have 1%, 2%, 5%, and what? 10%. The confidence level and the significance level must always add up to 100. When we divide these by 100, what we get is called the alpha level. So 0.01 and divide 2% by 100, 0.02, divide 5% by 100, 0.05, and then divide 10% by 100, 0.10. All right. Now we always use a two-tailed test for estimation. Now let me pick arbitrarily. If I were to pick, for instance, 95%, okay, we identify the significance level for 95%, it is what? 1%. This is alpha over 2. We're dividing this by 2. We divide this by 2. What are we getting? 0.5%. Then we subtract this 0.5%. The overall percentage under the two-tailed is 100%. So we divide this from 100%. We get 99.5%. Then we convert this to decimal. 99.5% is 0.9950. So we locate this inside the table, not outside the way we're reading it. We locate it from inside the table. What do I mean? Originally, if I were to read this from inside the table, 0.2275, if I trace it backwards, it's the same as negative 1, 2.0. Remember, I asked you to read 1.23. So 1.23 is 0.89065. But if I give you the probability 0.89065 and you tell me the Z, you simply add this number 1.2 and 0.03. Collectively, this gives us a Z of 1.23. Sometimes we not have the exact figure, they will give you 0.89063. You pick the closest. This can still qualify. At this point, we've been asked to read out the reading for 0.9950. 0.9950. So we're going to locate 0.9950 inside the table here. So so we'll go through the steps we had. Step 1, 9 of this 99%, sorry. And 9%, subtract from 100, we get 1%. 1%, we half it because the two-tailed, we get 0.5. 0.5, we subtract from 100, we get 99.5. And 9.5 converted to decimal, 0.9950. So we go inside the table, we locate 0.9950. Which numbers go to 0.9950? So we go down there, we check it out. You'll find that the closest figure is this one here. 0.99506. So this is 2.58. So meaning at 99%, we get 2.58. At 98%, step 1, identify the significance level, which is 2%.
Just a minute. 2.58, it's coming from where?
The 2.58, because when you go inside here, the 0.9950 is here. So you get the 2.5, you add the number who's on top there, 0.08. So when you get 2.5, this will give you 2.58.
Okay, I get it. Thank you.
Similarly, for 98%, I know it is 2.33. You need to master these ones here. But how do we get them? Step 1, find the confidence level, which is 98%. Significance level, 2%. Half of 2% is what? 1%. Okay. So try to continue there. 1%, what do we get later on?
Hundred minus 1, which is 99.
100 minus 1, which is 99.
Mhm.
Then
And then we express it in decimal.
decimal, yes, 0.9900. Then we locate it.
Check the table.
So 0.99 is the closest is here.
2.33.
Yes, 2.33. Okay. So 2.33 is the closest. All right, so this is how we get the 2.33. Okay, 95%. Step 1, 5%. 95% of the difference is 5%. Half of 5% is what? 2.5%.
2.5.
Then subtract from 100, 97.5.
0.5.
Then decimal point of 97.5% will be what?
0.975.
0.975. So Mr. Joseph, help us allocate the 0.975. What is it equivalent to?
Come again?
Help us locate 0.975.
0.975.
Yes. What is the Z for this probability?
0.9. 0.970. Five. Okay, it's on 1.9.
1.9 what?
6.
Good. 1.96. So it is here. It's exact 1.96. All right. So this is how we get the Z values. So this is 1.96. And when you follow the whole steps, this is going to be under 1.645. So this is how we find the Z figures here. So instead of going through these steps, these are the standard numbers that are usually given. But if you're given 97% or 80%, at least you know how to go about them. So I'll dominate on these ones for now. 99, 2.58. 98, 2.33. 95, 1.96. And 90, 1.645. Is that clear? All right. So we have established that our confidence interval is given by the mean plus minus z alpha over 2 the standard deviation over the square root of n. So I'll give two examples. Question 1a, we have our mean as 10, our n is 36, our standard deviation is 12, our confidence level is 95%. Okay, our confidence level is 95%. So we've been asked to find the confidence interval. So what is our answer? Confidence interval will be what? Mean. Where there's mean, we're going to put 10. 10 plus or minus. Where there is Z, we know 95%. What is our Z? 1.96. We just found it. And our standard deviation is what? 12 square root of n. Our n is what? 36. The square root of 36 is 6. 6 into 12 is 2. So 2 times 1.96 is 3.92. So the lower bound, we start first with the lower bound. 10 minus 3.92, what do we get? 10 minus 3.92.
6.18.
6.18. Good. Then we add 10 plus 3.92, what do we get?
13.92.
13.92. Excellent. Okay. Part B. Sometimes when you're not given the confidence interval, you're given what is called the proportion. The formula for the proportion is P plus minus Z alpha over 2. Then here PQ over N square root. So suppose we're given a proportion as 20% and you're given our N as 50 and we're given our significance level as 1%. Let us find the confidence interval for the proportion. So where there is P in decimal, we'll put 0.2. Now P and Q are related like confidence interval and significance level. If our proportion is 20%, meaning our Q should be the remainder from 100. Okay. Patricia, 1%. What is our Z at 1%?
It's 2.52. Oh, 2.58. So.
Good. It's the first one. 2.58. The table. 2.58. All right. Then our P is 0.2. What becomes our Q?
0.8.
0.8. And our N is what?
50.
All right. So calculate that. What is 0.2 times 0.8 divided by 50? Then you square root it. What are you getting as the answer? Mm-hmm. So 0.2 times 0.8, 0.2 times 0.8 divided by 50 equals 0.16. What is the square root of 0.16? What are you getting? What are you getting as final answer? 0.04, isn't it?
0.
Uh-huh.
145. Oh, when you
145.
when you multiply by the 2.58.
Yes.
Sorry.
Yes, and multiply by the 2.58. What are you getting?
Sorry, when you multiply by the 2.58, that's when you get 0.145.
Oh, okay.
9.4 something.
0.145. All right.
9.2 times 0.8 over 50. Square root. The square root is 0.05656.
0.5. Okay. All right. So this, then you subtract this minus that, what you get? 0. What?
0.055.
When you add
0.345.
good. So this is a confidence interval for the proportion 5.5% with 4.5%. Okay. So this is how the confidence interval question looks like. So sometimes you may also have two sets of data. Sometimes we may have two sets of data where we have x, y. All right. Then you have the mean, the standard deviation, and the sample size. Maybe here we have 15, and here we have 10. Here we have 5, here we have 3, here we have 30, and here we have 35. And we're given our alpha of 0.02. So when you have two samples, the confidence interval formula becomes Ci is equal to mean for the first sample minus the second mean, in short, the difference between the two means, then plus and minus z alpha over 2, and the square root of the first standard deviation, you square it, divided by its sample size, plus the second standard deviation, you square it over its sample size. So let's use this formula to substitute the data here. So what becomes our confidence interval here? What is our mean one? First mean is what? 15 minus the second mean?
10.
10. Good. What is our z? plus or minus our Z.
3.3, 2.33.
Yes, 2.33 because this is 2%. Then we put a square root there. What is our first standard deviation?
5.
5. This is sigma 5 squared over the sample size of what? 30
30.
plus the second standard deviation is what?
3.
Over standard deviation over the sample size of what?
35.
35. Good. So here, what's the difference?
5.
5 plus or minus 2.33 multiplied by, what do we get in here? 5 squared over 30 plus 3 squared over 35. You can compute it directly. So 25 over 30 plus 9 over 35. Okay, 1.09.
1.0.
Then you square root that answer. Get 1.044.
0.44.
So 1.044 we multiplied by 2.33. You get what?
2.433.
You get 2.433. Then the lower bound we subtract 5 minus that.
2.567.
2.567. Then when you add 7.433. All right. So when we go to an exam question, it looks something like that. An industry survey of people in sales management positions gave the number of years of experience in sales related positions. So we have sample size 80 and 70. Mean is X bar 21.7, 18.5, and standard deviation 9.3 and 4.8. So these are two samples. So the formula we're going to use is mean 1 minus mean 2, then Z, S1 over N1, S2 over N2. So we are asked to construct a 95% confidence interval. How many marks? 4 marks. So where there is the first mean, we put what? 21.7 here. The second mean, 18.5 here. Where there is Z, we're going to put 1.96 because coming from the 95%. Are you together so far?
Yes.
Mr. Joseph?
Mr.
Samuel, are you there?
Yes, I'm there.
All right, I'll send the recording. It's as easy as I'm trying to say it because people get confused in the exam. I'll send you the video so that it goes through. Then here we have 9.3 over its sample size, 80, plus 4.8 squared over its sample size, 70. All right, so when you multiply this to that, we get 2.76. So you subtract this, we get 0.43. When you add this, we get 5.96. So this is the confidence interval. This is for larger samples. This is for larger samples. Any questions before I move? All right.
Go back to the previous question.
The example or the actual question here?
No, the previous one.
The previous example? This one?
On the board. Yeah. The 2.33, where is it coming from?
So you need to master this table here because our alpha is what? 0.02. So
okay,
we
then I go to the
so you may be given at 9 or 1% or 0.01. All this is 2.58. You may be given at 8% or 2% or 0.02 in terms of alpha. All this is 2.33. So you need to know 95, 5%, 0.05 is 1.96. 90% or 10% or 1.0, it's 1.645. Are we together? All right. So for samples less than 30, our formula is confidence interval for one sample is simply the mean plus or minus a t alpha over 2 n minus 1. Standard deviation over the square root of n. This is one sample. If you're dealing with two samples, we deal with what is called the pooled mean. So we have mean 1 minus mean 2 plus or minus. I'd ask you to mute yourself because there's some noise in the background.
Hello.
Yes, please. I'd ask you to mute yourself. So alpha over 2 n1 plus n2. Then we subtract what? A 2. Then square root of pooled variance 1 over n1. Since this is variance, you put a square there. And 1 over n2. The variance is calculated separately. Its own formula is given by n1 minus 1, then the standard deviation for sample 1 squared plus n2 minus 1, and the standard deviation for sample 2. Everything n1 plus n2 minus 2. Now, when do we read the t table when the sample is less than 30? How do we read the t table? Step 1, you find the level of significance. Step 2, you half it. Step 3, you find the degree of freedom. The degree of freedom could be, if it's one sample, I'll call this part A. Simply subtract n minus 1. If it's two sample, I'll call it part B. you add the two samples, sample 1 and sample 2, and subtract the 2 because they're two samples. And finally, step 4, you read. Now this is the easiest table to read. Let's try, maybe if we have 95%. What is the significance level for 95%? Step 1, the difference from 100, which is what? 5%. Step 2, if you're given at 5% and your sample size is 10, what do you do next? You half this 5%, becomes 2.5%. Then, since it's one sample, you subtract 1 from it. So from 10, you subtract 1, you get 9. And finally, step 4, you read it. Now, this is how you read. When we go to the T table, the T table looks like this. This was a Z, and this is an F table, and this is the T table. So we started with 95%. The significance for 95% is what? 5%. So 0.05 is this one here. Then you divide it by 2, 0.025. Then n minus 1. So is 10 minus 1 is what? 9. So we go where there's 9 here. So it's 2.262. I repeat, 95%, and our sample size was what? 10. What we do? Identify the significance level, which is 5%. Okay, we are dealing with decimals. 5% is 0.05. The alpha is here. Alpha of 0.05 is 0.025. Then n minus 1 is what? 9. So check where there's 9. Let's try 98%. And if the sample size is 20. What do we do? Step 1. What do we do? Step 1. Yes, Patricia.
Significance level,
Which is what? 2%, right?
which is 2%, yes.
So in decimal for 2% is 0. What?
0.02.
Okay, half of it is what? 0.01, right? Then our degree of freedom is what? 20 minus 1?
19.
19. Which is this one here. Great. All right. Now suppose we had 99%, and we have two samples. We have 8 at sample 1 and 9 at sample 2. So 99%, our significance level is 1%, which is 0.01. Half of it is 0.05. Then you subtract 1 from each of them and add them, or just add them directly and subtract 2. So 8 plus 9 is 17. 17 minus 2 is 15. So you check here under 15, which is 2.602. So for two samples, we subtract 2. All right, so now I'll try part A. Find the confidence interval for the following. A, our sample size is 10. Our confidence level is 95%. Our mean is 5. And our standard deviation is um, our standard deviation is, maybe I'll put 3. So we are going to find a 95% confidence interval. So we know confidence interval is equal to x bar plus or minus t standard deviation over square root of n. So everything we're doing is the same, except that the reading is different here, the way we're reading. So our mean is 5. We're going to use a t because it is less than what? 30. So how do we read this t? Step 1, significance level, which is 5%, or 0.05. Half of it is 0.025, and n minus 1 at 9. Remember what we did, right? So when you go here, 5%, 0.025 at 9, 2.265. That is our t reading. 2.26 what? 2.2662? 2.262, yes. Then our standard deviation is 3 over the square root of n square root of 10. Alright. So what is the margin of error? Compute this part here. 3 over root 10 times 2.2. What are you getting? The square root of 10, then 3 divided by the answer, then you multiply it to 2.6, 2.262. So you get 2.146, 2.146. When you subtract, what are we getting? And when we add, what are we getting? When you subtract, what are you getting? 2.854.
2.854.
Good. This is the toughest when we're dealing with t, because most people get confused. Okay, together, let's try this one together. Suppose our mean is 100. Our sample size is 25. Our standard deviation is 10. Our alpha is 0.01. So what's the formula for confidence interval? Yes, in summary, confidence interval is what? Are we using Z or using T? Are we using Z or using T? We're using T because the sample size is less than 1.
Less than
Great. So what is our X bar? 100, right? And our T, how are we going to read T? Step 1, 0.01. Then half of 0.01 is what? What is half of 0.01? 0.001. 0.05. Then n minus 1, what is our n? 25. So 25 minus 1 is 24. So kindly help me locate the reading we're going to use. Locate the reading we're going to use. Quickly, without me hinting, what is the reading we're going to use? So 0.01,
0.
then under 20 what? 24.
24.
Okay, what do we have?
2.797.
Okay, 2.797. So here you put 2.797. All right, then our standard deviation here is 10 square root of what? 25. Square root of 25 is 5. 5 into 10 is 2. So here we're going to have 2.797 times 2. So our margin of error becomes what? Multiply this by 2. What are we getting? 14, 9, 15, 5. So when you subtract, what are you getting? And when you add, what are you getting?
94.406.
94.406. And when you add,
105.594.
594. Excellent. All right. So if you don't know, you cannot guess. If you don't know, you cannot guess. Finally, if you're given two samples, X and Y, okay, the mean, here we have 15, here we have 10. The standard deviation, here we have 3, here we have 5. And the sample size, here we have 8, and here we have 9. Then you're given our alpha 0.02. Remember the formula for a T confidence interval is got what? Mean 1 minus mean 2, the difference between these two means, plus or minus a T, then we have the put variance and 1 over n1 plus 1 over n2. So our first mean is what? 15. Our second mean is what? 10. Altogether on these two means, then the T, since there are two samples, Step 1, find the alpha. Step 2, half of this alpha is what? 0.01. Then there are two samples, we add them, 8 plus 9, 15. 17. 17 minus 1 minus 2, not 1, since the two samples 15. So when we go here, 0.02 and 0.01, and we go under 15, 2602. So where there is T, we put 2602. 2602. Okay. The put variance will calculate it separately. So our N1 is 8 and our N2 is 9. So remember the formula for the put variance. The formula for the put variance is sample 1 minus 1 times its standard deviation. Plus sample 2 minus 1 plus its standard deviation. I've given you the formula. Help me substitute. N1 plus N2 minus 2. So what is our N1? 8. 8 minus 1, 7. Times the standard deviation is what? 3. 3 squared. Be mindful, sometimes the examiner may put squared there, so meaning you don't need to square it here. Plus sample size 2, 9. 9 minus 1, 8. 8 times the standard deviation. What is the standard deviation? 5. 5 squared. Over N1 plus N2 minus 2, which is the degree of freedom itself, 15. So 8 plus 9, 17 minus 2, 15. So what do we get here? What do we get here? Please have your calculators quickly nearby. So 7 times 9 plus 8 times 25 divided by 15, 17.533. So 17.5 comes here. So the rest, at least you know how to go about it. Quickly, I only have 4 minutes. Let me take you to the assignment question of how this was done so that you can relate with what I've just explained. So here, the second question, we're asked to calculate the confidence interval to determine or it's just a remark that if you're dealing with a small sample size, you're going to use this formula. Mean 1 minus mean 2, alpha over 2 n1 plus n2 minus 2, so the put variance. If it's outside, you don't square it. If it's inside, you square it. It's the same formula. All right? So I'll end here, and I'll give you some homework. I'll end here, and I'll give you some homework to do. So unless there are any questions,